Hey there, welcome to my class on vectors. Today we're going to be learning about vectors. I'm super excited to be able to teach all about this stuff because it helps me learn my material better. And I hope it might help y'all, especially me, for when I need to study for finals in the future because I'm not going to remember this unless this helps me so much. Anyways, I have my notes right here. Um, I might pause a lot because it's my first video and I actually don't know the materials well. That's why I'm making the video. But I hope it's better than the professor's lectures. Anyways, vectors. We're going to start off with what a vector is. So a vector is something that has magnitude and direction. Like a vector. You know, vector. Anyways, this, like if you think about it on a graph, it's like a line that's going in a direction. So the line has a length, right? It's like yay long, and it's going in a direction, so we can call that a vector. Anyways, I'm going to write that down. Vector. Hope you can see this. Force, no, not force. Magnitude and direction. I lost my words. Magnitude and direction. So these are the two ways we can quantify a vector, and both of these are very important. So let's talk a bit about, let's see, a bit more about like these components of a vector. So imagine we have a 2D plane. So this is our plane. I would say like graph or coordinate plane, but I don't want to go into coordinates and I just want to go into planes. And this board is perfect. So we have a square right here. You see that square, okay? So in the square, I can have a line. Now this line, I can move around. Like let's say I take it and I put it right here. It's great right there, right? Or I put it right there, or there. It's the same length, pretend it is, and wherever I put it, it's just a line, and we're not really caring about the direction. So this is the magnitude. Like if this one has a length of 3, this one has a length of 3, this one has a length of 3, all of these have the same length, or as we say, the same magnitude. Magnitude is another word for like size. So like the strength of the size, I don't know. It's essentially how big it is. So the magnitude of this is 3. Another example is like force. Like it's going in this direction with a magnitude of like 10 newtons. So it's not an actual physical distance like in meters, but that is a distance measurable by the force. We'll get into more on that later, especially with the newtons in the work. Anyways, now let's apply direction to all of these. Each of these vectors has, or not vectors yet, each of these lines is at a different angle. While they all have the same magnitude, let's put some arrows on them. Arrow there, arrow there, and arrow there. So now each of these vectors, because they're vectors now, is something that has a magnitude, and B, a direction. It's going somewhere. This one is going from point A to point B. This one's going from point D to point E. Each of them has a beginning point and an end point. And you can change the length of the vector. Like you can make a vector that's as long as this whiteboard and put an arrow on the end of it and be like, this is my vector that goes along the whiteboard at an angle of 35 degrees. So I hope that helps you understand what a vector is. Now let's start getting into the math of this. Let me erase this. Okay, next. How to write a vector. So let's say I have a vector that we're going to pretend this is on a coordinate plane, but I'm actually going to put on a coordinate plane that goes from point A, which is at like x3, y5, to point B, which is at point, I don't know, like 8, 13. 13 is a good number. Lucky number 13. Anyways, so how do you like define this vector? How do you write on a paper, oh, I'm talking about that vector? So there's a few different ways you can do it. One is you can take the points A and B. You can say I have vector AB because it goes from point A to B. So A to B turns into AB. And most often, people will also put an arrow on the top of a vector. So that's actually a little close. You can write it like this. Vector A, B. You put an arrow on top, just be like, dude, guys, it's a vector. Anyways, these can be whatever letter you want. Like, it can be point omega to point, I don't know, plant. It's just a letter to tell us, like, that's the point we're talking about. So you can be A, you can be B. Most often, I've seen it A to B or U to V, which I really don't like because my U's and V's look the same. So we have a vector and we have coordinates. So these coordinates describe the point. But when we're talking about vectors, we're talking about something that goes from a point to a point. So how do you say with like a coordinate thing, describe a vector? Like, how do you do that? So the concept of this is that a vector has its own defined length, its own defined magnitude. Like, this is always going to be the same length. It matters not where you put it. So even if these two coordinates are different, they're always going to have the same not relativity, I think, but like the same relative position. So if I take A and I put it at like, I don't know, 103, 105, the resulting vector is going to be at 108, 113. This is because the magnitude and the direction of the vector haven't changed. I've just changed its position, the location of it. Let's pretend that these are the same length just for the sake of this conversation. I probably should have made it better. So it doesn't really matter where the vector is. It just has a starting point and an end point that are relative to each other. So how do we actually write that? Well, it's pretty simple. How do you get the distance between 2 points? Well, you can do, it's related to the distance formula, but that's actually how you determine the magnitude. The magnitude of it is the distance. And I forgot one thing with the naming conventions. You can assign a letter to a vector. Like, this is vector A. Done. Vector A. And that's kind of not related to the fact that I put A, B here. It's just vector A. I can make it vector omega because I really like Greek. Vector omega. And that's a vector. And I'm going to call it vector omega, and we're going to be happy with it. But don't let me confuse you. Most of the time people use letters. I just think it's cool to use Greek letters. So we're just going to name this vector V. V. And we can put an arrow on top of it, but I'm going to keep it as vector, just V, the letter V, because for me that's simpler. So how do we describe vector V? Well, the conventions for describing a vector are as follows. So it's going to be similar to a coordinate, but not quite. So keep in mind that these are two relative points. So what we're going to do is describe the relative position of point A to point B. So the way to do that is simply just find the distance between each coordinate. So what's the difference from 8 to 3? It's 5. So if you have 3, you just go 5 to the right, or 5 this direction on the x-plane, and boom, we got it. The y, 5 to 13, that's 8. That's up 8 on the y-axis. So 5, 8. And as you can see, this is a horizontal movement of 5 and a vertical movement of 8. That's how we got from point A to point B. And then all you have to do is boom, boom. You put some angle brackets on the end. I thought they were chevrons or less than equal signs. Whatever they are, this is how you write a vector. So I can start at any coordinate. Any coordinate. I can start at 15, comma 19. I start at this coordinate, which uses the parentheses. I don't know, I was about to call it a curly bracket. But you start 15, 19. Well, this vector has the initial point of 15, 19. We're just saying so in this first example. And so that's, we move it over 5. We move it up 8. 8. And we have our endpoint. And that is going to be 20, 27, if I did my math right. Boom. Vector. And this is still vector v. I'm going to put the letter v as its name because it's still vector v. Pretty simple. Now I want to draw your attention to two things. One, if you divide the y by the x, that's literally the slope of a line, because we got these two values by doing, I'm going to draw it over here, x2 minus x1, comma, y2 minus y1. That sounds pretty familiar, right? If we just take this and replace it with the division symbol, actually it's the opposite. It has to be y on top. If we put the division symbol right there and put y2 minus y1, we just got the slope, because it's the change in y over the change in x. How simple is that? And a vector is just describing the change in x and the change in y between two given points. It's as simple as that. That's what a vector is. And the second thing I want to draw attention to is the fact that we made a triangle right here. So we have a triangle. Pretty obvious, right? But remember that when we're talking about triangles, we can use trigonometry. Trigonometry is going to play heavily in what we're about to talk about here in a few minutes, because, like this, I can take the angle, this, whatever angle it is, and I can project it to other parts. If I have 5 and 8, and I have this, I can find the angle here and do a bunch of mathematical wizardry that I'm going to talk about here in a few minutes, or actually in the next video, because I might end this one right now. Anyways, that's your introduction to vectors. Let's see what's next. One more definition is, this one's kind of important, the word scalar. So there's a difference between a vector and a scalar. Scalar. A scalar is only magnitude. Remember the lines I was talking about at the beginning? Those were scalars. And we just call them that because we want to. A scalar is literally just a magnitude. So this can really be anything. Like, it can be 20 newtons, it can be the length of a door, it can be miles, it can be a temperature. The thing is, you don't have a direction with that. So you don't have, if you have like 20 feet, it's like 20 feet to where? Like 20 feet towards the door, 20 feet in that way. It's like there's no direction, so it's a scalar. And it's just a number. If you're a coding guy, it's just an integer. And it's only half of your vector. Once you assign a direction to your magnitude, boom, it's a vector.